Hey class, today we are going to do your day 7 notes, which is still on scientific notation like day 6 was, except today we're going to be comparing numbers in scientific notation, figuring out how many times bigger one number is versus the other. So first we have how many times larger is the diameter of the sun, which is this, compared to the diameter of the earth, which is this. Okay? So if I want to know how many times bigger one number is versus another, we usually divide them, right? So we want to look at, well, which is my larger one? Okay, when I'm looking at numbers in scientific notation, I know the larger one is the one that has the larger exponent. So this one's to the 6th power, this one's to the 4th power. So this one is larger, and it does say how many times larger is the sun. So I'm going to take the larger number, 1.3 times 10 to the 6th. Oops. And I'm going to divide it by 1.3 times 10 to the 4th. Okay, so now when I'm dividing numbers in scientific notation, I can just think of them in parts, just like we did when we did our exponent rules. I can look at the part that's just the plain old numbers. I've got 1.3 divided by 1.3. Well, 1.3 divided by 1.3 just equals 1. Okay? Then I can look at my exponent part. Okay, if I'm dividing exponents and they have the same base, we've learned that we can just subtract those exponents, right? So that would make 10 to the 6 minus 4, oops, which makes 10 to the 2nd power. All right, so if I'm taking this divided by this, my answer is just whatever I get when I divide these two numbers. So it would be 1 times then the difference of those. Those would be 10 to the 2nd power, so 1 times 10 to the 2nd power. So that's how many times bigger then the sun is compared with the earth. Now, let's write that as an actual number. 10 to the 2nd power, or would just be 100, right? 10 times 10 is 100, so it's just 1 times 100, or 100 times larger. All right, so that's how many times larger then the sun is versus the earth. All right, so we're going to look at another similar one. It says how many times larger, again, is the distance to Jupiter, which we have right here, than the distance to Venus, which is right here. Okay, so I'm going to do the same thing as what I did before. So I'm going to take this one, the larger one, divided by the smaller one. So I've got 7.5 times 10 to the 10th divided by, well, I noticed something. This one's in standard form, this one's in scientific notation. It is way easier to deal with the numbers when they're in scientific notation, so we're going to rewrite this in scientific notation. So let's see, if I move my decimal over to make it between 1 and 10, that would be 4.2 times 10 to the, well, let's see, my decimal went from here to there. We've got 1, 2, 3, 4, 5, 6, 7 places over that we moved it. Okay, so now they're both in scientific notation, so now I can go ahead and divide them like I did up here. Okay, so the first two numbers. So 7.5 divided by 4.2, right? I'm just looking at the regular old numbers and dividing those. Well, let's see, that's not something I just know off the top of my head. So I'm going to type in my calculator, see what I get with those. So 7.5 divided by 4.2. And that makes lots of yucky decimals there, 1.78, etc. So we are going to just round it to about 1.8. Okay, and then over here, if I'm comparing my exponents, 10 to the 10th and 10 to the 7th, well, if I'm dividing them, that means I'm actually subtracting those exponents. So that would make 10 to the 3rd power. So then my answer is this and this together. So 1.8 times 10 to the 3rd power. Okay, so that's how many times bigger Jupiter, distance to Jupiter versus distance to Venus. But again, I want to write that as an actual number. So what would that be? Well, multiplying by 10 to the 3rd power is just going to move my decimal 3 places over. So 1, 2, 3, right? 1, 2, 3. So it's 1,800 times larger, or farther, I guess it was. All right. And that's it. So when you want to compare two numbers in scientific notation, how many times bigger one is versus the other, you just simply divide them and then use your rules with your exponents, divide your coefficients there.